Hey, welcome back to the channel. Microsoft just unveiled all new 5 for mini flash reasoning, a compact 3.8 billion parameter model designed for logic and max intensive tasks in your mobile, edge, or low latency environment. Today, I'm going to break down how it's achieved 10x higher throughput and 3x lower latency while delivering the top tier reasoning performance. And this breakthrough is driven by the revolutionizing hybrid decoder architecture. So you heard me right. It's not an encoder or decoder, it's a decoder architecture called Samba Y. It combines state space modeling with attention mechanism to redefine on device reasoning speed. These flash models are optimized for constrained compute memory and latency environment, delivering the fast interference without sacrificing any reasoning quality. The Pi 4 is reasoning model, which is like 3.8 billion parameters, but relatively small compared to other model. But how it's been enabled the 3x faster interference and production level, low latency without compromising that. I'm gonna show you how it's gonna works in real world scenario. I'm gonna demonstrate it. I spin up the Pi 4 environment for you, and I'm gonna walk through it like with giving the reasoning skill state and how it's gonna performing. So let's explore how the mathematical task, how faster the interference is giving to us, and how it's maintaining the efficiency, and how this model is like going to be a small model with powerful logical reasoning that support the 64 token context. And let's see is like how it's gonna be ideal for long sequence reasoning, allowing and maintaining the logical coherence over the extended context. What's new in this? It's a hybrid decoder architecture. The core of this Samba Y, it's groundbreaking innovation featuring a gated memory unit. This architecture is combined a self decoder that's integrated with the number state space model. So what actually it's making the kind of like powerful? It's because this is having a integrated Bamba state space model and sliding the window attention with full attention key value caching and with cross decoder that alternative between the GMU and cross attention. So unlike other hybrid models, so it has two phase of reasoning, right? So what does it means? Like it has a self decoder. It's a one phase of like reasoning, which is allow to have the Mumbai system with the window attention and full attention caching, and followed by the cross decoder, which alternative between GMU and across the attention layer. So this setup deliver a very significant advantage by achieving up to 32 token context understanding within a fully decoder based hybrid architecture. So it's key to understand because the smaller LLMs is the go-to selling product for the upcoming ones because they wanted to sell the smaller LLMs. So it's not only the faster interference with kind of like very good two-step or three-step or multi-step reasoning capabilities that's enabled them to give a more significant advantage when it's compared to their fellow competitor Gemini 2.5 Flash. It has two stages of reasoning. I think Pi 4 Mini even they're gonna have that. But this model is having that multi-step mathematical reasoning and demonstrated a proof of concept in test, uses a less memory and operated in efficiently in low latency environment, supporting a long contextual workflows. So in a synthetic benchmarks or mathematical benchmarks, it outperformed higher tier models and Pi 4 Mini. flash reasoning achieved a significant score of 92.4 in Maths 500 benchmarks, showcasing its ability to generate a prompt and contextual output quickly. And you need to know, right, so what are the kind of like technical prerequisites like it's required to deploy this model. It's PyTorch 2.6 and Transformer 4.461 and an accelerator. So when I'm gonna show you that as well in my upcoming video where I'm gonna show you right how to install and fine tune Pi 4 for your organization level. Watch it for my upcoming video. And as usual, Microsoft has always prioritized the responsible AI, incorporating the safety pipeline with supervised fine tuning and direct preference optimization DPO and reinforcement learning with human feedback loop that's enable it right to minimize any harmful outputs, and it's understand that context, and it's gonna gives you more dialer based answers without any jailbreaking or any harmful in text or context due to the prompt persons. And how this model is performed the best in on-device mathematical reasoning. It's blazing fast. I'm gonna show you how it started, like how it's gonna giving the responses. So let's see it into a kind of like Azure Cloud AI Foundry where I've created a mini flash reasoning in action. We are gonna testing with simple query what is the weather in Santa Clara and try to see how faster it's gathering the information, how it's going to show that. And I'm gonna try into Azure Cloud Factory a simple project that verify the setups and start the modeling, and it's gonna give it into the one. All right, so let's get started. I'm gonna show you that how we are gonna use that, and I'm gonna ask a simple mathematical one with multi-step reasoning. So what does it means like a rectangle and a square together have total parameter of 80 centimeter. The square's side length is twice the smaller side of the rectangle, and additionally the area of the rectangle is 96 centimeters, right? What are the side lengths of the both the shapes? So it's a multi-step reasoning one, and let's start it like giving it and see how it's gonna performing it. So the moment I have given this one, the Pi Mini reasoning, it started like going through, and it has done a kind of like throughout the summarization of that, and just started calculating the both the parameters size with the mathematical formulas, and it started giving the reasoning to it like the 5x plus y is gonna be 1, and it's gonna be getting into the answer to it. And let's see is like the Pi 4 mini reasoning, which is one that I'm using it at this moment. Let's see like how we are gonna utilize this, right? And it's a multi-reasoning, right? So that's where it started like thinking and trying to give the answers to it, and it took a longer in terms of the giving the answers, but in Pi 4 mini flash will not gonna take this much longer to give the answer. That's where it's outperform in terms of like giving the answers to it. And we can start fine-tuning guardrails and started like exploring it like how faster it is gonna give the one's answer. Let's see is like how many multi-step reasoning it's trying to do it, and wait for the answers what is gonna be the correct answers it's gonna come to it. And it's derived into the kind of like understanding, alternatively maybe a, a typo total parameters it's taking it, and then it's trying to analyzing to it. So I can change this in the contextual information as well, because if I do that, it is going to be more mathematical reasoning one. I can add a sessions as well. I can give the multiple examples to the ones, and I can start deploying this model as a web model straight away. When somebody wanted to utilize this model, we can do it. So we have the agents and templates and fine tuning the ones. I'm gonna have a one more session into the Azure AI Foundry, how we are gonna utilize that and started like playing to the ones. So it's come to a conclusion, thinking it like the x value is gonna be 4 and x is equal to 6 or ones. For y is like the ones, and it comes to the mathematical one, right? To giving answer. But the similar answer, if you're given to ChatGPT 4 and try to see is like how faster it's going to give the responses to us. Let's open the same one into the ChatGPT, right? And say it like how faster it's going to give the similar answers, right? So I pasted this here, and it's define x and y. It's take the 80 and 40 and checked some kind of like a plugin, and the conclusion, there are no real solution for this problem concern, because why? Geometry is over constrained, making a square length is too small into the ones. The summary, there is no real solution for this problem. What I'm trying to ask it, that's what it's gonna say it, right? So but we know, right, how to, it has to do a multi-step reasoning and come up with the answers to us. That's where like the models are like the answer. Even if I say anything, it's going to take it. Yeah. So thanks for watching it. I will gonna give you more similar kind of a context, and you started playing with the new models. Thanks for watching. Please like and subscribe if you like this video.